By this time, alam nyo na kung paano mag-differentiate ng isang function and to find the area under the curve using integrals. So yung differential calculus was developed to address the tangent problem, while integral calculus was developed to address the area problem. So kung titignan natin, yung tangent and area problems, mukhang hindi sila related. Pero actually, they are closely related. In fact, differentiation and integration are inverse processes. And itong fundamental theorem of calculus relates the two processes precisely. There are two parts of the fundamental theorem of calculus. The first part relates the process of differentiation and integration. The part 1 of FTC states that if f is continuous on the closed interval ab, then the derivative of the definite integral from a to x f of t dt is equal to f of x, where a and b are real numbers and x is between a and b. To understand this, let us break down each component of the theorem. First, the function f is continuous on the closed interval AB. So dito sa figure natin, we will be using the t-axis instead of the x-axis kasi yung x is gagamitin natin as the upper limit of our definite integral. So the definite integral from a to x of f of t dt is illustrated in this. So yung x natin is between a and b at ito yung area na sinasabi ng ating definite integral. This expression gives the area under the curve from a to x. Now, since x is a variable here, we can say that this definite integral is actually a function of x. In other words, the integral of f of t from a to x should be seen as a function of x. Now, this equation tells us that if we take the derivative of this integral, we will arrive at the original function in terms of x, regardless kung ano man yung value ng ating a. So let's have some examples and find the derivative of f of x equals the definite integral from 0 to x of the square root of t cubed plus 4t dt at x equals 2. So for our solution, using FTC part 1, so f prime of x is equal to d over dx of the definite integral from 0 to x of the square root of t cubed plus 4t dt. By FTC number 1, pwede lang nating ilagay yung x doon sa t's natin. So that is now equal to the square root of x cubed plus 4x. But since we are looking for the value of the derivative at 2, then i-evaluate lang natin yung derivative at 2. So that is f prime of 2 is equal to the square root of 2 cubed plus 4 times 2, or that is square root of 8 plus 8, or that is now 4. Example number 2, let's find the derivative of g of x equals the definite integral from negative pi over 4 to x of the square root of sine squared t plus 1 dt at x equals pi over 3. So for our solution, we have g prime of x is equal to d over dx of the definite integral from negative pi over 4 to x of the square root of sine squared t plus 1 dt. By FTC1, pwede na nating i-substitute yung x dito sa ating function, so that is square root of sine squared x plus 1. And since we are looking at the value of the derivative at x equals pi over 3, we evaluate g prime of x at pi over 3. So we have g prime of pi over 3 is equal to sine squared of pi over 3 plus 1. In degrees, pi over 3 is 60 degrees. Or that is now the square root of 3 over 2 squared plus 1, or square root of 3/4 plus 1. So that is now the square root of 7 over 4, or the square root of 7 all over 2. For this example, hindi na lang x yung nasa taas. So we now have x squared. So how will we answer this problem? So let's find the derivative of h of x equals the integral from 5 to x squared of 1 over t dt. So what we want to do here is magamit natin yung FTC1. At kailangan raised to 1 lang yung ating variable dito. We do that by letting u be equal to x squared and du over dx is equal to 2x. Kukunin lang natin yung derivative ng u natin. Okay? At magagamit natin ito mamaya sa ating solution. So, we know that h prime is equal to d over dx of the definite integral from 5 to x squared of 1 over t dt. Or that is d over dx times the integral from 5 to u of 1 over t dt. Kasi nga 'di ba, pinalitan na natin yung x squared ng u. Now, the problem here is with respect to x yung kinukuha nating derivative, pero etong ating integral is a function in u. So, paano natin ngayon gagawin na itong definite integral natin dapat maging function siya in x? Or, pwede din naman na yung derivative natin dapat with respect to u. Doon ngayon papasok yung ating chain rule. Kaya natin kinuha kanina yung du over dx. So, we now have d over du, the definite integral from 5 to u of 1 over t dt, times du over dx. So, napansin ninyo, parang yung d over dx, parang hinati natin into 2. That is, derivative of this with respect to u, para pwede nating magamit yung FTC1, times, by using chain rule, we have du over dx. Para bumalik pa rin siya doon sa kanyang original variable na x. By using FTC1 here, this is just equal to 1 over u times du over dx. Pero sabi natin, di ba, u is equal to x squared and du over dx is equal to 2x. So, this becomes now 1 over x squared times 2x. And pwede natin i-cancel yung isang x dito, which leaves us with 2 over x. Let's find the derivative of j of x equals the definite integral from x squared to x cubed of t squared dt. So parang same doon sa example number 3 natin kanina yung ating solution, pero this time, yung lower at upper limit natin ay parehong variable in x. So we let c be an element of the closed interval x squared x cubed. So kung ito yung ating x squared at ito yung ating x cubed, andito yung ating c. Now we know that meron tayong property, di ba, na kapag kinukuha natin yung definite integral from here to here, pwede natin siyang paghiwalayin like ito plus itong part na to. So, we can rewrite now j of x is equal to the definite integral from x squared to x cubed of t squared dt, which is equal to, paghiwalayin natin using c, we have the definite integral from x squared to c of t squared dt plus the definite integral from c to x cubed of t squared dt. Now, taking the derivative of that, we have j prime of x is equal to d over dx, the definite integral from x squared to c of t squared dt plus the definite integral from c to x cubed t squared dt. Now, the problem is, kailangan di ba constant yung nasa baba? Pero in this definite integral, constant yung nasa taas at yung variable yung nasa baba. But we know that kapag binaliktad natin yung upper and lower limit, pwede nating makuha yung definite integral nito, pero ni-negative natin siya. So, by using that property, we now have the negative of the definite integral from c to x squared t squared dt plus the definite integral from c to x cubed t squared dt. Or that is, ayusin lang natin, the derivative of the definite integral from c to x cubed t squared dt minus the definite integral from c to x squared t squared dt. Now, pwede na natin siyang paghiwalayin kasi nga dalawang terms na to. So we have d over dx of the definite integral from c to x cubed t squared dt minus the derivative of the definite integral from c to x squared of t squared dt. Just like in example number 3, we let u be equal to x cubed and the derivative is 3x squared and v be equal to x squared with derivative 2x. From there, ito gagawin nating u at ito gagawin nating v. So we have the derivative of the definite integral from c to u of t squared dt minus the derivative of the definite integral from c to v t squared dt. But since this is a function in u and this is a function in v, hindi naman siya x, gamitin natin yung chain rule. So we have d over du of the definite integral from c to u of t squared dt times du over dx minus d over dv of the definite integral from c to v of t squared dt times dv over d. By FTC1, this is now equal to u squared. Okay, yung u nilagay lang natin sa t squared. So u squared times du over dx minus, eto naman by FTC1, this is v squared times dv over dx. But we know that u is equal to x cubed, v is equal to x squared, du over dx is 3x squared, and dv over dx is 2x. So by substituting those values, we have x cubed squared times 3x squared minus x squared squared times 2x. So kung ipapasok na natin yung 2, so imumultiply natin yan, ganoon din yung 2, imumultiply yan. So we have x raised to 6 times 3x squared minus x raised to 4 times 2x squared. Then since multiplication ito, we add 6 and 2, 4 and 1. So we have 3 times x raised to 8 minus 2 times x raised to 5. The second part of the fundamental theorem of calculus naman provides us a way to find the definite integral of a function between two limits using the antiderivative of that function. So, FTC2 states that if f is continuous on the closed interval ab, then the definite integral from a to b of f of x dx is equal to the antiderivative of f at b minus the antiderivative of f at a. So let us see why this theorem makes sense by relating it to the first part of the fundamental theorem of calculus. So suppose we have a function f that is continuous over the interval between c and d. So c and d ang gagamitin natin kasi yung a and b magiging limits natin later. Now, let us define the function capital F of x as the area under the curve between c and some value x. So that is, etong area na to, that is capital F of x equals the definite integral from c to x of f of t dt, where x is between c and d. Now, the first part of the fundamental theorem of calculus tells us that kung yung f natin is continuous over the interval, okay, over this interval, then capital F of x is differentiable at every x in the closed interval CD. And capital F prime of x is actually equal to f of x. So in other words, capital F of x is an antiderivative of f of x. Now, using this, gamitin naman natin yung limits natin na a and b instead of x. So, f of b now is equal to the definite integral from c to b of f of t dt, and this is illustrated by this graph. Tama? Yung capital F of B natin ngayon, ito yung area na kanyang kino-cover. On the other hand, capital F of A is equal to the definite integral from C to A of F of T dt. Ito naman yung area na kanyang kino-cover. Okay? By definition yan ng definite integral. Now, since we have the two, meron tayong area here from C to B at meron tayong area from C to A. What is then the area from A to B? That is this area. And what is this area? This is actually capital F of B minus capital F of A. Diba? Galing dito sa dalawang to. Pinag-minus natin yung capital F of B sa capital F of A. And this area here can be represented in terms of definite integral as the definite integral from A to B of f of t dt. So that shows us that fundamental theorem of calculus part 2 is valid. Now, using FTC2, let's evaluate the definite integral from negative 2 to 5 of x raised to 4 dx. So for our solution, syempre, kunin muna natin yung antiderivative ng x raised to 4, which is x raised to 5 over 5. Diba? By our power rule, magpa-plus 1 lang tayo dito and then divided by kung whatever man yung result doon. Then, we evaluate that from negative 2 to 5. So, that is capital F of 5 minus capital F of negative 2. So ngayon, if we evaluate that, so capital F of 5 now is equal to 5 raised to 5 over 5 minus capital F of negative 2 is negative 2 raised to 5 over 5. Or that is 3,125 over 5 plus 32 over 5 or 3,157 over 5. And that is 631.4. Next, let's evaluate the definite integral from 0 to 3 of 8x cubed minus 3x squared plus 2 dx. So, since pwede natin kunin yung definite integral ng each term, okay, so ituloy na natin, we have 8 times x raised to 4 over 4 minus 3 times x cubed over 3 plus 2x evaluated from 0 to 3. We know that that is capital F of 3 minus capital F of 0. So, by simplifying, that is now 2x raised to 4 minus x cubed plus 2x evaluated from 0 to 3. So, evaluating, that is now 2 times 3 raised to 4 minus 3 plus 2 times 3 minus 2 times 0 raised to 4 minus 0 cubed plus 2 times 0. Or if we simplify, that is 2 times 81 minus 27 plus 2 times 3 minus, eto lahat ng to, 0 na lang lahat yan. Or that is 162 minus 27 plus 6 or 141. Now, let's evaluate the definite integral from 0 to 2 of x raised to 1 half times 2x squared minus x dx. So, the problem here is multiplication. And we know that hindi natin pwedeng kunin yung product ng individual integrals. So, what we should do is i-distribute muna natin yung x raised to 1 half doon sa loob para maging difference na lang siya. So, that is definite integral from 0 to 2 of 2x raised to 5 halves minus x raised to 3 halves. So, in this case, dalawang terms na siya, wala nang multiplication, so pwede na nating paghiwalayin. So, we have now 2 times x raised to 7 over 2 over 7 over 2 minus x raised to 5 over 2 over 5 over 2 evaluated at 0 to 2. So that is capital F of 2 minus capital F of 0. By simplifying, we have 2 times 2 over 7 times x raised to 7 over 2 minus 2/5 times x raised to 5 over 2 evaluated from 0 to 2. or that is 4 over 7 x raised to 7 over 2 minus 2/5 times x raised to 5 over 2 evaluated at 0 to 2. So we now have, evaluate na natin to at 2, 4 over 7 times 2 raised to 7 over 2 minus 2/5 times 2 raised to 5 over 2 minus 4 times 7 times 0 raised to 7 over 2 minus 2/5 times 0 raised to 2. So lahat ng ito magzi-0 na lang siya. So we now have 4 over 7 times 8 square root of 2 minus 2/5 times 4 square root of 2. Minus, syempre alam natin magzi-0 lang yan. Or that is 32 square root of 2 over 7 minus 8 square root of 2 over 5. Or, kapag ginawa nating similar fraction, that is 160 square root of 2 minus 56 square root of 2 over 35, or 104 square root of 2 over 35. And in decimal form, that is approximately equal to 4.20. Now, let's evaluate the definite integral from pi over 4 to pi over 3 of cosecant squared x dx. So for our solution, we know that the antiderivative is negative cotangent x. So we will evaluate that at pi over 4 to pi over 3. So that is capital F of pi over 3 minus capital F of pi over 4. So that is negative cotangent of pi over 3 minus the negative cotangent of pi over 4. Note that pag ginawa nyo ito sa inyong calculator, dapat naka-radians kayo, hindi degrees. Or else, magmamali yung inyong sagot. So that is now negative square root of 3 over 3 minus negative 1. So that is negative square root of 3 over 3 plus 1. Okay? Or kung gusto nyo pagbalik ta rin, pwede din naman. So that is 3 minus square root of 3 over 3, or in decimal form, that is approximately equal to 0.42.